conversation on quadratics, and up until now we've pretty much stuck with the vertex form of a quadratic, and today we're going to add another form of this quadratic. We're going to add what we call the standard form of a quadratic. F of x is equal to ax squared plus bx plus c. This is called the standard form. And standard form is a little different from vertex form. It has advantages and it has disadvantages. Let's first look at what can we get from standard form that we can get from vertex form without changing anything. First of all, if we look at this a value, this is the same a value that we have in vertex form. And if a is greater than 0, we know that we have a smiley face function. If a is less than 0, we know that we have a frowny face function. None of that is any different from what we had in vertex form. We also know that this value of a, if we take its absolute value and it's greater than 1, we've got a stretch. Our function is going to stretch up big and tall. It's going to be tall and skinny. And if the absolute value of a is between 0 and 1, then we have a shrink. It's going to be a vertical shrink. It's going to come down closer to the x-axis, and it's going to be short and fat. But what else is different? Well, first of all, there's something that we can get from this function just by looking at it that we can't get from the vertex form. And that is use this c value here at the end, whatever this c value is. That c value is going to give us the y-intercept. And whatever that constant is at the end of our function is going to be where this crosses the y-axis. So my y-intercept has a value of 0c. So I got something new from this, but what are we missing? What have we not seen? What can we not just look at and get that we could just look at and get in vertex form? Well, obviously that's the vertex. So we have to have a different way to find our vertex if our function is in standard form. And how we do that is we can use the equation x equals negative b over 2a. And as long as our function is set out in standard form, where we have ax squared plus bx plus c, I can find the x value of my vertex, which incidentally will also be the axis of symmetry, by simply looking at negative b over 2a. Well, what about the y value? To find the y value, I have to do f of x, which in this case means I have to do f of negative b over 2a. I'm going to substitute that negative b over 2a back into my function and find my y value. So my coordinates are going to be negative b over 2a for the x value, and then f of negative b over 2a for the y value. So we can do things a little differently when we're working on this, but we can still find all of the same information that we could find on our other type of quadratic function. All right, so let's see if we can clear our screen here and put in an actual example of this. So let's set this up, and we will actually look at a value of a quadratic and look at what it graphs and how we find all of the information that we need. Let's take the function f of x is equal to x squared plus 2x plus 3. And we'll use a fairly simple one to start our process here. Now let's figure out what the graph is and what the vertex is and what the axis of symmetry is. Well, first of all, we look at this a value and there's nothing there. Remember, if there's nothing there, it's equal to 1. So obviously a is greater than 0. So we know the general shape of our parabola. This is going to be a smiley face. It's going to open up. And since a is equal to 1, then we have no stretch and no shrink in our function. No vertical stretch, no vertical shrink. It's going to look just like a standard parent function. And we've also seen in our last screen that this 3 here on the end, this constant term, is going to give me my y-intercept. So my y-intercept for this function is going to be at the point 0, 3. That was pretty easy. We just have to look and get that. Now here's the part we have to do a little more work on. We need our vertex and our axis of symmetry. And if we find our vertex, we have our axis of symmetry. Our x value is negative b over 2a. So what's the b value in this function? And what is the a value in this function? Well, the b value in this function is 2, and the a value in this function, even though it's not written there, is 1. So this is going to be negative 2 over 2 times 1. And if we simplify that, we get negative 2 over 2, and negative 2 over 2 is negative 1. So now what do I do with that negative 1? I know that that's going to be my axis of symmetry. I now need my y value. Y is equal to x squared. So negative 1 squared plus 2x, and x is negative 1, so we substitute negative 1, plus 3. If I come back and simplify that, negative 1 squared is 1. 2 times negative 1 is minus 2, plus 3, and that gives me a value of 2. So the vertex of this function is at the point negative 1, 2. So let's graph this. If I come back and graph this, I'm going to graph me a nice little coordinate plane here. And we'll mark off our units. And then let's talk about what we know. We're going to put these in units of 1. And you really should always label that so that somebody knows what they're doing there. And let's make this red and then make it a little easier for us to see. All right, so what do we have? We know that the very first thing we found was that we have a y-intercept at 0, 3. So let's put in our y-intercept at 0, 3. So we'll come back to that in a second. We know that we have an axis of symmetry at x equals negative 1. So here's my axis of symmetry at x equals negative 1. And if I have an axis of symmetry at negative 1 and I'm going through this point 0, 3, I'm also going through this point negative 2, 3, because if I'm going 1 to the right of the axis of symmetry, I have to go 1 to the left of the axis of symmetry. So I've already got 2 points there. But what about the vertex? The vertex here is at negative 1, 2. So here's negative 1, 2, right on my axis of symmetry. So I have my points. I could do another one here if I wanted to. I'm going to go up 4 and over 1, which gives me a point right here. And then if I go 2 to the other side of my axis of symmetry, I'm here. And then these 2 are good points on my graph. So here is the graph of my function. And I found that from, instead of from the vertex form, from the standard form of my graph.